Let's pick up with where we left off last time. We had, this is in 3-2. We had just a little bit at the end of 3-2 we hadn't finished. Remember, we started talking about the multiplication rule. And so, yes. Hang on. We have done notes on all of 3-1 and most of 3-2. So we're finishing up the end of 3-2, and then we're going to do 3-3 today. When you come back Thursday, we'll do 3-4, and that's the end of it. Are you saying there's another?
Question 3 and 4. Might as well just.
Let me look and see. That's where we are. That's what we're doing. Yeah. This is number 3 on that section. Okay, now, the probability that a particular knee surgery is successful is 0.85. Find the probability that 3 knee surgeries are successful. So let's review a few things we talked about last class. First of all, we talked about probabilities that are conditional. Remember, if you have a deck of cards and I draw a king and I hold on to it, and then I go to draw the next card, and I ask, what's the probability of getting a queen? What did we discover? Listen to the question again. Remember, I said you may need to study cards because you're going to see questions related to cards. If I have a deck of cards and I pull out a king, when I started, how many cards were in the deck? If I pull out a king and I hang on to it, when I get ready to draw the queen, how many cards am I drawing from? That means that the probability changed for drawing the queen from what it would have been if I drew it the first time. When that happens, we say it's a conditional probability because what happened on the first draw affected the probability of what's going to happen on the second draw. Those events are dependent. What happened on the first thing changed the probability of the second. Now, if I had put that king back in, would it have made a difference when I went to draw the queen? No, because then I'd still have all 52 cards there, all right? So here's what we got to figure out. If the probability that a knee surgery is successful is 0.85, does what happens on the first surgery affect the likelihood of the next one being successful? I hope not, because if I'm the third guy in a row having surgery and I know every time the chance of success is going down, that's not a good picture, okay? I want to be first on the docket. It shouldn't make any difference what happens on one surgery when it comes to the next one. So if I want to know the probability that 3 knee surgeries are successful, all I have to do is what? Multiply, what's the probability the first one's successful? 0.85 times what's the probability the second one is successful? Times what's the probability the third one is successful? You guys tell me what that equals. How about 0.614? Now, the probability that 3 in a row will be successful is not as good as the probability each individual surgery is successful. But that's because the probability that an individual surgery is successful is not 100%, right? So it's kind of like when you're flipping a coin. Eventually, the other thing is going to show up, all right? On this, since it's not 100% success on a surgery, it's going to lower, you're going to get a greater chance that eventually one of them is going to be unsuccessful, okay? Now, could you tell me how to figure this out? Find the probability that none of the 3 surgeries is successful.
0.25. No, 0.15.
Hold it. Okay, I want the probability that none would be successful. So what do you think?
100 minus the 85 that is.
Okay, you said 100% minus the 85%, or 1 minus 0.85 is a likelihood of it being unsuccessful is 0.15 on one surgery, right? So, Daniel, you said you would multiply those 3 together, 0.15 times 0.15 times 0.15, right? Y'all think that sounds right? And what do you get? 0.003. Now, that makes me feel better that it's not very likely he's going to have 3 unsuccessful surgeries in a row. So that's a very low probability. Now, can you figure this one out? Find the probability that at least one of the 3 is successful. How do you do that?
0.85.
Well, okay, I've got a proposal. She said 0.85 times 0.15 times 0.15. That would give me the probability that the first surgery is successful and the other 2 aren't. But this says find the probability at least one is successful. So as long as one is successful, it doesn't matter if it's first, second, or third, right? Would it be okay if 2 of them are successful?
Yes.
Would it also be okay if 3 of them are successful? What's the only thing that's not okay?
If they were all unsuccessful.
If they were all unsuccessful, now put on your thinking caps. We talked about this last week. How would I find, what's the easy way to find the probability that at least one is successful if I know the probability that none are successful? What am I looking for?
I think like about 1 in 3.
Okay, let me give you a little diagram and let's see if this helps. Okay, let's say that we're talking about these surgeries here. Okay, and we have this tiny little probability that none are successful, which is 0.003. Wouldn't that mean that anything else that happens, 1 of them successful, 2 of them successful, all 3 successful, they're all out here? What are we actually looking for? What's that called? When I want everything except this. Starts with C. Complement. It's the complement. Remember, the probability that none were successful was 0.003. So that would mean that the probability that at least one is successful would have to equal 1 minus the probability that none are successful, because it's everything else, right? So what's that going to end up being? What did you guys decide? What is that? .997. I'm looking for the complement. That's the easiest way to do it, because otherwise I've got to get the probability the first one's successful and the other 2 aren't. And then I'd have to get the probability the second one's successful and the other 2 aren't. And then the probability the third one. Now you go back and pick 2 of them, and then I got to get all 3, and then I'd have to add all those together. That's way more work than doing 1 minus the complement. Okay? So keep that in mind. When you figure out what it is you're trying to find, ask yourself if finding the complement would actually be easier. Okay. I know how you guys love word problems, so we got a little paragraph here. Anybody planning to go to med school one day? Okay, got a few of you guys. Do you know how that works? Do you watch Grey's Anatomy? If you watch Grey's Anatomy, hopefully that's not how it works. I would hate to think there's all that going on in the operating room during a surgery. But as far as getting into med school, more than 15,000 U.S. medical school seniors applied to residency programs in 2009. Obviously, this data is a little outdated. Of those, 93% were matched with residency positions. 82% of the seniors matched with residency positions were matched with one of their top 3 choices. Okay, now are you following what that's saying? If you don't understand, here's the way it works. Let's say you get your bachelor's degree, you're planning to go to med school, you have to take your MCAT, kind of like you take an SAT to go to college, you have to take an MCAT. So then you would apply to go to medical school somewhere. And what this is saying, that out of those who applied, 93% got a residency position, okay? And actually, this is after they finish med school and they want to become a resident. Sorry, I put that in the wrong order. But only 93% of those coming out of med school actually got to be a resident somewhere. 82% got matched with one of their top 3 choices. So here's the deal. When you start applying for a residency program, you're going to put down, here's my choice A, choice B, choice C, and then the places that are going to take these residents have their own ranking system, because they know who the pool is out there, and maybe they're going to take 20 residents. They've got a list in order of who they want. So if you end up getting matched with somebody who also said they wanted you, that's considered a match. Now, it's possible somebody might say they'll take you and it wasn't one of the ones that you necessarily wanted to go to, but that still means you got a residency position. So that's the difference here. Is that making sense? 93% got a position, only 82% who were matched with a position got one of their top 3 choices. And so this is explaining how the medical students rate theirs, the program directors rate theirs, and match simply means that there was an overlap and you were on their list and they were on your list. Okay, deal? Now, find the probability that a randomly selected senior was matched with a residency position and it was one of the senior's top 3 choices. Now, let me back up for a second, because we need to make sure we have down the percentages that they gave us. I see 2 of them. What's the first percentage? And 93% represents what?
Oh, no.
Matched with a residency position. So you jot that down somewhere, because we're going to need that. So 93% were matched with a residency position, and then 82% got one of their top 3 choices, right? And it's 82% of those matched with a position got one of their top 3 choices. Now, let's see if you can answer this. Find the probability that a randomly selected senior was matched with a position and it was one of their top 3 choices. What do you think that's going to be? When we see an and, what should it make us think about? That sounds like a multiplying problem, doesn't it? Okay. So what do you think you might need to do? How many were matched with residency position? What percent? And then if it says, and it was one of their top 3 choices, we're going to do what? Multiply those together. What do you get? If I take the 0.93 times the 0.82, that should be my answer, right? Because 82% of these guys got a position in one of their top 3 choices. 0.763. Does that make sense? What was my clue that I was going to need to do this?
No, like my question is, like, why did you, okay, so you chose 0.93.
Right. I want the probability that they got a residency position and it was one of their top 3. So the probability of getting a residency position was 0.93. The probability that they got one of their top 3 choices, given they got a position, was 0.82. And so you multiply those together because of what word? And. That's what told me I needed to multiply those, right? Are we good? Okay. Find the probability that a randomly selected senior who was matched with a residency position did not get matched with one of their top 3 choices. How would we calculate that?
0.93 times 0.18.
Now, I want to point something out. Let's go back here for a second. Notice it says, find the probability that a randomly selected senior. This is from the whole group of everybody who was coming out of med school, right? Okay, were some of those people who did not get matched into a residency program? Yes, so that's why we had to use the 93%, because only 93% got matched. Now look at this question. Find the probability that a randomly selected senior who was matched with a residency position did not get matched with one of their top 3 choices. Do I need that 0.93? Or am I only looking at the group that did get matched? But now think about this for a minute. If I multiply the 0.93, okay, times something, that means I'm including, I'm asking this question as if I just randomly collect or pick any senior, and they might not have gotten matched anywhere. Does this tell me I am restricting myself only to the group that got matched? Because it says a randomly selected senior who was matched. So I don't need the 0.93. That's the only group I'm working with. I am looking for those who did not get matched with one of their top 3 choices out of the group who did get a residency position. You see what I'm saying?
So 93% were matched.
Okay, let's make sure we understand. Hang on. Shh. Back up a second. Back up a second. Let's make sure this makes sense. Okay. You've got a group of seniors in medical school, and they're applying for residency programs. Do all of them get a position as a resident somewhere?
No, 10% down.
Only 93% actually get to go on and be a resident somewhere. All right. So if I'm talking about all seniors, it includes the ones that don't go past medical school. They didn't get to be a resident anywhere. They basically did so poorly in medical school, nobody wants them as a doctor. And you should thank those people for not choosing them if they're that bad. Okay, now, out of the ones who do go on to get a residency position, it says only 82% of those got matched with one of their top 3 choices. So do you understand what this is saying? If I were to put this in a little diagram for you, and maybe that would help. Let me put this up here on the board. Okay. You've got 100% in the box of everybody who's a senior coming out of med school, okay? Almost the whole thing, but not quite, get to go on and be a resident somewhere. And out of this group, this many get one of their top 3 choices. So you see how this is sort of set up. Everybody's in the box, but some of these people didn't get to go on and be a resident. So there's 93% of all these seniors inside this group. And inside this group, 82% of them actually got one of their top 3 choices.
Yes.
Okay, so what we did when we answered the first question, I want you to look at the way this is worded. It says, find the probability a randomly selected senior was matched with a residency position. So what's the likelihood they're in the big circle, not the big box, but the big circle? There was 93% chance that they were in the big circle, and it was one of their top 3 choices. That's why we had to multiply the 0.93 times the 0.82, right? Because I only wanted the ones that were inside the small circle, and I had to get the probability they were in the big circle times the probability that they were also in the small circle. Now, look at this question. Find the probability that a randomly selected senior who was matched with a residency position. Am I looking at the big box now?
No.
I'm only looking in the big circle. You see what I'm saying? These are the only ones who got matched with a residency position. And out of that group, 82% got one of their top 3 choices. So what's the probability that if I'm picking out of the group that got a residency position, that they didn't get matched with one of their top 3 choices? Say that one more time, Tamarian. What did you say? Is he not, wasn't it Tamarian that said it? Did you say what it was? What is it? It's 18%. Why is it going to be 18%? Yeah, because that 93% meant out of everybody. We're only looking at the 93% that actually got matched with anybody. And out of that whole group, that's one, a probability of 100% in that group got matched somewhere. 82% got their top three, one of their top three choices. That means 18% went somewhere that wasn't one of their first picks. That you have to think about in order to find, right? Okay, how you doing? Okay, let's look at section 3.3. Now, events can be mutually exclusive. What does that mean? They can't occur at the same time if they're mutually exclusive. Like, tell me if this is possible. Can you be breathing and not breathing at the same time? That doesn't mean hold your breath. I mean, either your breathing is in your alive and not breathing is in your dead at the same time. Or is that impossible? Can you be alive and dead at the same time? How can you be alive and dead at the same time? No. That's different. Either you're one or the other, okay? It's mutually exclusive. I cannot be both at the same time, okay? Can I be in the pool, like underwater, and completely out of the water at the same time?
Are you in something?
Oh my goodness, you guys are driving me bananas. Okay, mutually exclusive. Listen, it's impossible for it to happen at the same time. Now, events that are not mutually exclusive can happen at the same time. Like, is it possible for it to rain and have the sun out at the same time?
Yes.
It is, isn't it? They may not happen, it might not happen that way very often, but it's not necessarily mutually exclusive. And you start looking for the rainbow when that happens, right? Now, see if you can tell me if these are mutually exclusive. Event A, I roll a die, I get a 3. Event B, I roll a die and I get a 4. Can both of those happen at the same time with one die?
No.
That's what? Mutually exclusive or not? If it's mutually exclusive, it means it cannot happen at the same time. It's mutually exclusive, okay? I cannot roll a single die and get 2 different numbers on that roll, okay? Now, how about this? Is it mutually exclusive or not? Randomly selecting a male student and randomly selecting a nursing major. Is that mutually exclusive or not?
No.
Because could I have a student who is both male and a nursing student at the same time?
Yes.
There you go. Not mutually exclusive. Now, we said what little word told us we needed to multiply probabilities together? Having a hard time talking. If we see this little word, or, that means we're going to add. Okay? If I have this happen, or this, that tells me I'm going to be adding those probabilities. But I've got to be careful when I'm adding because of the idea of whether things are mutually exclusive or not. Think about it for a minute. If I were wanting you to add up the probability that you're wearing a red shirt or you're wearing black pants, okay? So anybody who's wearing a red shirt, you get counted in that group, correct? Anybody who's wearing black pants, you get counted in this other group. Do I have anybody in here who would have been counted in both groups? I think Brooklyn would. She's got a red shirt and black pants. So that means she got counted. There's probably some more of you. I just can't see everybody.
What about short? What if you're...
It could be anything, Daniel. So the deal is, it's possible, if things are not mutually exclusive, if it's possible that you could be in both groups, you may have something that got counted twice. That's not accurate if I count that same event or that same person in two places, right? So here's the deal. Make sure you don't forget that you have to subtract out the probability of A and B, both of the things occurring, from the probability of A plus the probability of B. You got to subtract out the extras that got counted more than once. Yes? Yes, you will. Okay? As long as they are mutually exclusive, what would be the probability that A and B happen at the same time? 0. So that's why it doesn't matter as long as they're mutually exclusive. I don't subtract anything out. Okay, so here we go. You select a card from a standard deck. Find the probability that the card is a 4 or an ace. Now, the first question you want to ask yourself is, am I supposed to be adding or multiplying? What word tells me which one to do? Or tells me to add. Now, I got to ask myself, are these mutually exclusive? Can I have a card that's both a 4 and an ace at the same time?
No.
I hope you say no. That is impossible. So as long as it's impossible, can you calculate the probability that when I draw a card, it's either a 4 or it's an ace? Because how many 4s are in a deck?
4.
4 of them. How many aces?
4.
If I add those together, I get 8 out of the 52 cards. And I could turn it into a decimal, or I could reduce the fraction, and I would come up with 0.154, a little over 15% likelihood that just drawing a card at random is either an ace or a 4. All right, so far so good? So let's change it this way. Find the probability that if you roll a die, you roll a number that's less than 3, or you roll an odd number. Now, tell me something. Is it possible that I could roll a number that would be both of these?
Yes.
What would be an example?
1.
1
That's it.
is an odd number. 1 is also less than 3. So are these mutually exclusive? No, they are not. So how would I calculate the probability on this? Okay, you said we would add. So let me go here. And let's do this real quickly. We want the probability that we get a number that's less than 3, or the probability that we get an odd number. All right, so the probability that I get a number that's less than 3 is what? Okay, numbers that are less than 3 would be 1 and 2, right? Is 3 less than 3? No, so don't count it. So 2 out of 6 would be less than 3. You tell me or means that I add. So what's the probability I get an odd number? There are 3 sides that are odd out of the 6. 1, 3, 5. So 3 out of 6, but we figured out this isn't mutually exclusive. How many numbers were in both of these? What number was included in both places?
1.
1. 1 was less than 3, and 1 was also odd. So I have to subtract out the 1 out of 6 that I counted in both of these places. Does that make sense? If I add them up, but it's not mutually exclusive, I counted the 1 here, but I also counted the 1 here. So I've got to take out where I overcounted. Think about it. If I want the probability that I get a number that's less than 3 or odd, let's figure out what that should be. How many sides would meet that? 1, 2, those are less than 3, and then what else is odd? 3 and 5. There should have been 4 sides. If we don't subtract out where we counted 1 in both places, we get the wrong answer. If I add this together now, 2 plus 3 is 5. 5 minus 1 gives me 4 out of 6. Does that make sense? Okay. So 4 out of 6, which is 2/3, 0.667. All right, hang on. So look at this. We've got a frequency distribution showing the volume of sales in dollars, the number of months in which a sales rep reached each sales level during the past 3 years. So if this pattern continues, what would be the probability that the sales rep will sell between $75,000 and $124,999,000 next month?
That's water.
Yeah, it sounds like rain.
I don't want to
Okay.
ride the bus.
I know. Hopefully it'll pass over quickly. All right, guys. Tell me what would be the probability that the sales rep would sell between this amount and this amount next month? What were you going to say? Or you got a question? Yeah. Okay. Sure. Let's back up a second and we'll talk about this one. Since we wanted the probability that the number is less than 3 or odd, we had to decide, was it mutually exclusive? In other words, is it possible to have both of these things happen at the same time? And it is, because 1 is less than 3, 1 is also odd. And that's one of the sides on the die. So that means we take the probability of this event plus the probability of this event, but we subtract out the probability that both happens, because one got counted here and it got counted here. Because 2 sides were less than 3, 1 and 2. 3 sides are odd, 1, 3, and 5. But because 1 got counted in both of these places, we take out the overcounting. That's the probability of being both. The only number that was both less than 3 and odd was 1. And so that's why it works out this way. Does that make sense? As long as they're mutually exclusive, what will be the probability of both happening? You guys told me a minute ago. 0. If they're mutually exclusive, it's impossible for both of them to happen at the same time. So it's really the same formula. It's just this part never comes into play when they're mutually exclusive, because that's always going to be 0 for the probability. Okay? So let's go back to this one. See if you can give me the probability that the sales rep is going to sell between this amount and this amount next month. How would you calculate that?
Would you add up all the months and then the
Yeah, so tell me, is this mutually exclusive? Is there anybody that got counted in more than one category? No, because it stops at $74,999 and then it starts at $75,000. These are all mutually exclusive. You got counted in one place and only one place. So should I just be able to add those together and divide by how many months we had? Yeah. What do you think?
Yeah.
All right, so you guys tell me, what do you get when you do that?
4 over 9 or 4.4.
Okay, so if we add these two up, we know we've got 16 in the numerator. Adding up all the months, there were 36. So 16 out of 36 is 0.444. All right, so far this is not terribly difficult. Agreed? The trick is when you see an or, you just got to ask yourself, are these mutually exclusive? But you know you're going to be adding them. If I see an and, I'm doing what? Multiplying. Okay, now here is a table showing blood types. All right, so anybody planning to go into nursing, you got to be careful with this. You have blood types that either have positive or negative RH factor. Anybody in here know you have RH negative blood? It's not very common, but yeah, if you do have it, you have an RH factor. It's either positive or negative. Most people are RH positive. Few people have negative, okay? Now, you also have different blood types. There's type O, type A, type B, type AB, and then we've got these columns with totals. We've seen tables like this before. Hey guys, shh. Looking at this information, can you tell me what you think is the most uncommon blood type? AB negative. If I look at these boxes in here, the one that's definitely the smallest is this one. AB negative is going to be your rarest blood type. What do you think is the most common?
O positive.
O positive, and then A positive is pretty close behind, okay? Now, here's what you're gonna answer. A donor is selected at random. Find the probability that the donor has type O or type A blood. Okay, so find the probability the donor has type O or type A blood. What does that mean I'm gonna be doing? Adding or multiplying? Adding. Now, what are you supposed to ask yourself? Are those mutually exclusive? Can you have blood that's both O and A at the same time? It's yeah, it's just one or the other. So these are mutually exclusive. So hang on. Tell me how you would calculate the probability of this.
The total, well, total of O.
Total of O is 184, right?
uh,
And the total of A is,
164.
so you add those together and then do what? Divide it by 409. And that would be the probability that it's either type O or type A, correct? Oops, I went a little fast over that. Let me go back again. Okay, so about 85% is the likelihood. Now, we'll do this one and then we'll hit the pause button. Find the probability that the donor has type B blood or is Rh negative. Are we going to have to do something different on this? Yes, we are, because they're not mutually exclusive. You can have B negative blood. So how are we going to calculate this?
45
So you would take the 40, are y'all listening? Some of you are talking. You would take the probability of type B is 45 out of 409, but then you would do what? Count up how many are Rh negative, plus 65 over 409, but you better do what at the end? Excellent. These guys got counted in this column and in this row. They got counted twice, so we subtract out 8 over 409.
102.
So 102 over 409, which is about 25%. So far, are we okay? Okay, yeah, we are done. That's it. So we have finished the notes on 3-3.